UV unwrapping can be a lot of work and not all objects really need it. You can use box mapping, sometimes called triplanar mapping, as a quick fix. First, create the usual mapping nodes by selecting the material and pressing Ctrl T. Set the texture coordinate to generated. Choose a texture. Change the projection type to box. This projects the texture from all sides of the model. To avoid these sharp edges, you need to set a blend value so the different angles of the textured projection blend into each other a bit. 0.25 usually does the trick. With object coordinates, you can assign an object to drive the texture coordinates. For example, this empty. You can use it to control the position in 3D space of the texture, as well as its rotation and scale. Auto Smooth is a great feature in Blender that creates smooth surfaces without a high polygon count. To use it, first you need to turn on Shade Smooth, then turn on Auto Smooth. An angle of 30 degrees works well in most cases. This means that every angle under 30 degrees gets smoothed out. Every angle over 30 degrees stays sharp. In other words, you don't need to use a Subdiv modifier in support loops, keeping things very low poly. It's an efficient and fast modeling technique for objects that don't deform. Keep in mind, this only works inside of Blender. So if you need to export your model to another program, use support loops and Subdiv modeling instead. Bool Tool is a really awesome cutting add-on that comes with Blender by default. Make sure the box is checked so that it is active in preferences. Create an object that you want to use to cut into another object. Select it, then shift select the other object that you want to cut into. Press Ctrl 1 to cut. Now you can see that the cutter object has become a bounding box. This allows us to see through it while still giving us the ability to select it and move it. The Boolean operation updates in real time. The cool thing is that this is a completely non-destructive way of modeling. You can set the model to smooth shading with Auto Smooth, and you will need to repeat that last step for the cutter object as well. The cutter object is also called the brush. If you don't want to learn the shortcuts, in the option panel under the Edit tab, you'll find all the Bool Tool options. This chair has an interesting piece of wood that twists around itself. How do you model that? Let's delete that part and start from scratch. Select the faces at both ends and right-click. The Loop Tools menu gives us some extra modeling options like Bridge. If you don't see these options, make sure the Loop Tools add-on is activated in Preferences. Now that we've selected Bridge, the faces are bridged. In other words, they are now connected by new faces. The original faces are removed. To create the twisting effect, we need to add more edge loops first by increasing the segments. Then create the twisting effect by increasing the twist value to 3. To bring out the subtle edge reflections of the wood material, I added a bevel modifier. It's set to angle. One easy way to create holes in a flat surface is to bevel the vertices. First, create some edge loops with Ctrl R and increase their amount if needed with the mouse scroll wheel. Then select the vertices where you want to create holes and press Shift Ctrl B to bevel them. In the bevel menu, increase the number of segments and set the profile to 0.1. This creates a circular profile. Make sure the pivot point is set to individual origins. Now you can add some depth to these bevels by extruding them. Extrude by pressing E and then scale them down by pressing S and moving the mouse. Press G and C and move the selection down along the Z axis. This creates a nice beveled edge. Make sure that Auto Smooth is turned on and that the model is smooth shaded. Then extrude down again to create the depth of the hole. This hole is the result of a Boolean operation. As you can see, some unnecessary vertices are left over. We can fix this in a couple of ways. First, we can select them and then merge them one by one, or we can turn on Auto Merge Vertices. Then just slide the vertices to their neighbors by pressing G twice. The vertices are then merged automatically. Now we just have to repeat this step. To create some support loops around this hole, the easiest way is to select the inner faces and press I to inset, but don't move the mouse. Then press Alt S and scale the selection inwards. Now add an edge loop on the inside with Ctrl R. Subdivided, it looks perfect, no boolean issues left. If you want to avoid n-gons and boolean artifacts, modeling with quads is the way to go. For a round hole you don't actually need that many loops. 3 edge loops per side of this cube will do. Press Ctrl R and press 3 on the numpad to add 3 edge loops. Now select 4 faces in the middle and inset them by pressing I and moving the mouse. Right click and from the Loop Tools menu choose Circle. The Loop Tools add-on needs to be activated in Preferences. Inset the selection again slightly and extrude down a little bit by pressing E and Z to create some support loops. Extrude further down and create some support loops there as well, if you like. Now we've got a hole with perfect quad topology. Making stairs is easy now with custom bevel profiles. Start by beveling an edge using the Ctrl B shortcut. Then open the bevel menu. Increase the segments and profile as needed. Turn on Custom Profile. You can now choose several presets. Stairs and molding presets will come in handy for architectural visualization. There's also a support loops option. You can even create your own custom profile. Note that this does not work in Blender builds before 2.82. Sliding a vertex along an edge is easy. Just press G twice and move the mouse. But what if you want to move it along the same angle but in the other direction where there is no edge? Start the same way by pressing G twice and sliding the vertex in one direction of the edge. Then press C and move it in the direction you want. I was curious how the talented @Zugamasta on Twitter made this animation. Fortunately, he shares the file on the Blender website. First of all, it uses the new cloth physics, which includes something called pressure. Pressure is a keyframeable value which deflates or inflates objects. When we fill in a positive value and press the spacebar, the simulation starts and the model gets inflated and starts to float a bit. The amount of pressure you need depends on your object. In the beginning, this object has a pressure of -2, so it gets kind of sucked into itself. Then these collision objects squash it. They are not visible in the render. Next, they move away from one frame to the next, and at the same time, the pressure is increased from -2 to 70. This causes the object to inflate and then unsquash itself. To quickly add a subdivision modifier, instead of adding it in the modifier stack, press Ctrl and a number from 1 to 5. You can then use this keyboard shortcut to toggle between the subdivision levels, and Ctrl 0 turns the modifier off. It does not work with the numpad keys, only the top row of numbers from 0 to 5. Bonus tip: if your goal is to make a perfectly round sphere, a subdivided cube is not the way to go, unless you add a cast modifier and set it to sphere factor 1. Alternatively, you can activate the Extra Objects add-on, which adds the round cube to the primitives. First, turn on the Polybuild tool. In edit mode, when you mouse over an edge, it will become highlighted. Drag it to extrude a new face, or Ctrl drag to extrude a triangle. Repeat that on an edge of the triangle to turn it into a face. Hold Shift and click on a face to delete it. Ctrl click to create new vertices. Select all with A and press F to fill. Ctrl drag a corner vertex to create a face from that location. Together with the Shrink Wrap modifier, or with snapping turned on, you can use this tool for manual retopology. Here's 3 ways to do a bouncy ball. Method 1. First, set some keyframes for the location by pressing I and moving the ball with G. Then in the graph editor, select the keyframes, press T and choose Bounce. Method 2. Set the ground plane to rigid body and make it passive. Reduce the friction and increase bounciness to 1. Set the ball to rigid body and keep it as active. Reduce the friction and increase bounciness to 0.5. Method 3. Enable collision for the ground plane, enable soft body physics for the ball, turn off soft body goal, and set bending to 10. Turn on stiffness. Make a flag-shaped plane with enough subdivisions. Add the vertices on one end to a vertex group. Add a cloth modifier and add the vertex group to the pinning group. Start playing this simulation by pressing the spacebar. Add a force or wind to the scene, either will work. And add some more force to the wind, a value of 5000 for example. Experiment with the vertex mass. This value depends on your object. You can experiment with the different cloth presets. Turn on self-collisions so the flag doesn't intersect with itself. Create a floor plane and set it to rigid body passive. Create a ragdoll from a bunch of cubes. Set all the cubes to rigid body active. If we play the simulation now by pressing the spacebar, they all fall down. So far so good. Now to connect all the body parts, select 2 at a time and go to the object menu, rigid body, connect. In the connect menu, set it to point. Select the connection and set disable collision to off. Repeat this for all the parts that should be connected. Parent everything except the floor to a new empty so you can easily move it around. Hide the relationship lines in the overlay options. Play the simulation and check that everything works. For a bit of fun, create a new object and set it to rigid body passive and check animate it. This way you can play with the ragdoll in real time.